Hello and welcome from the A-Level Chemistry team at Long Road Sixth Form College. My name is Simon. I've made this presentation to give you an insight into the course and to give you some help with completing the summer work that we'd like you to do before joining us in September. Now, there are several reasons for this summer work. The first is we want to give you a good idea of what A-Level Chemistry will be like. What kind of content will it cover and what kind of knowledge and skills will you develop while doing it? Second reason is we want to help you to recap the key knowledge and skills from GCSE, because obviously the A-Level will build directly on a GCSE course, and so it's going to be important to have those ideas and skills fresh in your mind when you begin. Thirdly, we're very keen to encourage you to develop your interest in chemistry, and we really hope the task we've put together will help you to do that by giving you an insight into how chemistry is used in the wider world. And finally, we want to give you some challenge over the summer, something more difficult to think about, something to get your teeth into and to stretch you a bit and make you think about things you haven't done before. So those are the aims. What's it going to involve? Well, in total, you're going to have to do 5 tasks. I'm going to go through each of the tasks in turn in a moment. 4 of them are going to be compulsory. So tasks A, B, C and D are compulsory. You must do those. But then you can choose either E, F or G to be the 5th one. And you can pick which one of those you do according to your interest. And whichever one you pick, though, you're going to find they're much more challenging than the first 4. So that's the overview. Let's look at the tasks in turn. Task A is some multi-choice questions, and they're based on concepts which are going to be important in term 1. Now, it's pretty obvious what you'll have to do here. You'll have to select the correct answer, either A, B, C or D. But if you find them hard, don't worry. Okay, what it means is you will know which lessons you have to ask questions in during the first few weeks, and we will know if there are any areas of GCSE that we need to go over again. So that's the purpose of task A. Task B is very similar. It's balancing equations, and again, you will have done this before, but it's a key skill, and it's worth checking you've got this right before we go any further. So there are 10 questions, and they've got the formulae there. The formulae are correct. You won't need to change the formulae, but you'll need to balance them by putting numbers in front. So all you would have to do is put the numbers in front of the formulae where I've put the blue boxes in order to balance the equation. Some of the equations are going to look very familiar, like the 2 I have on screen there, and the compounds there will have been encountered at GCSE. Some of them will look a bit different, and it might test you a bit more on the balancing. That's task B. Task C is data analysis, and here we want you to plot a graph and interpret the data and see what it tells you. And the data is shown there in the table. It's for the decomposition of dinitrogen pentoxide, and so we've got the time that the reaction has been happening for and the mass of dinitrogen pentoxide that remains. Now you can plot the graph on real graph paper, or you can do it electronically in Excel or in another program. It doesn't matter. What's important is you plot a good graph and that you can interpret what it shows you. Bit of advice is to be very careful with the x-axis scale. Now, if you look at the table, you'll see that the rows of the table do not have an even increment between them. It goes up by different amounts between each row. However, your graph, the axis, the x-axis, should have an even increment in the scale. So think carefully about how you're going to plot that graph properly. And the full instructions to this task do give you some pointers. I should also say that you're not expected to know anything about this reaction. You don't need to know anything about dinitrogen pentoxide in advance, and you don't need to look up anything about it. It's simply a data analysis task. All the information you need is in the question. Task D is to do with the development of atomic structure, and this is where the A-level course will begin in the first week of term. So we want you to look at the key scientists involved in determining the model of atomic structure that we now use. So I've listed them there. There's Thompson, there's Geiger, Marsden and Rutherford, Bohr, Moseley and Chadwick. And we want you to write a brief summary of the contribution of each of those scientists or groups of scientists. What did they find out? What experiments did they do? As a summary. And then we want you to select one scientist or one group of scientists and produce a PowerPoint going into their work in more detail. So looking in more detail at the type of experiment they did and what measurements they made and what that told them about atomic structure. Now you won't have to present your PowerPoint to the whole group. That would be very daunting in the first week of A-level. But what you will have to do is bring the research with you and be prepared to discuss it with other students. Okay, so it'll be used in discussion and group work rather than a full presentation. Having done the 4 compulsory tasks, you then get a choice for the 5th one, so either E, F or G. And these are deliberately designed to be more challenging and to get you thinking more deeply about chemistry, and in particular about organic chemistry. And you can choose which of these tasks you do according to your interest. Now there's an introduction section that applies to all of them, and I'll show you that in a moment. And then you can choose either task E on environmental chemistry, task F on the chemistry of fuels, or task G on medicinal chemistry. And you can pick which one you like based on which one you think is going to be more interesting. Now, I said there's an introduction that you have to do first. This is common to all tasks. So whether you pick E, F or G, you'll need to read through this introduction very carefully first, because it looks at ways of representing organic molecules. And you can see there are 5 ways of representing the molecule ethyl ethanoate shown on the screen now. You may have come across ethyl ethanoate at GCSE. It's an ester, and it's fairly easy to make it in the lab. At GCSE, you've probably seen full structural formulae like I've got on the top left there, but there are other ways of representing organic molecules too. We want you to start to learn a little bit about that in these tasks. In particular, skeletal formulae. So that's on the middle picture on the left there. What does that mean? How does it relate to the full structural formula? And the introduction will take you through that. And it will show you how to compare those 2 types of structure with the 3D shape shown at the bottom. And there's a very useful little program that you can access to look at some molecules in 3 dimensions. So do the introduction first, read through that, and then you can pick which task you think is the most interesting. Now, you might be interested in environmental chemistry, in which case you could pick task E. That will look at some notorious chemicals that have had a negative environmental impact. So the 3 molecules are listed there. There's tetraethyl lead, freon, and something called red dye number 2. So having done the introduction and learned how to represent these molecules, you can study their structures, and then you can do some research on their environmental effects and why red dye number 2 is coloured in the first place. That's task E. Task F, you might find interesting, chemistry of fuels. And so there are some common fuel molecules at the top. There's the skeletal formula of 2,2,4-trimethyl pentane, which is common in petrol. Again, having done the introduction, you will understand what that representation is showing, and you can compare it with some of the other molecules on the screen. This is a bit more mathematical, this choice. There are some calculations about how much energy is released when the fuels burn. And so if you're more mathematically inclined, this one might appeal to you. And then you can do some research about the composition of different fuel blends and the use of the molecule at the top right there, nitromethane, in drag racing cars, and why that's a useful fuel for that purpose. If you're interested in medicinal chemistry, or you have a career in mind for the future involving medicine, you might find task G is the most interesting for you to choose. Because this one is looking at some drug molecules, and there are 3 of them on the screen there. Thalidomide in the middle is a particularly well-known one. Again, having done the introduction, you will understand these representations, these skeletal formula, what they tell you about the structure. And you can look at their 3D shapes, because the 3D shape affects the function of the drug molecule. And so if you choose this task, you'll be doing some research on the effect of shape on the function of these drugs. What resources do you have available to help you? Well, you can get MoleView is a very useful program. It's free and it's on the internet, and you can access it very easily. It's very user-friendly, and you can see on the left there's a white background panel there where you can draw the structure you want to look at. So I've put in the carbons and the nitrogens and the bonds between them. And then you can convert that into a 3D model, and you can rotate the 3D model around. You can examine the shape, you can look at the bond angles and get a feeling for what the molecule is like in 3D, and that will help you in all 3 of these tasks. There's also a very good interactive periodic table. This is available at ptable.com, and there's various ways of displaying the information there, and you should find that very useful in completing many of the parts of this preparation work. So I'd strongly recommend looking at those 2 resources. You'll probably find that the work takes around about 10 hours in total. Obviously, it's going to depend exactly how you do the research and which task you pick, but something like 10 hours in total. I would imagine tasks A to D, the compulsory ones, taking about 6 or 7 hours, and task E, F or G taking around 3 hours each by the time you've done the introduction as well. So that gives you some idea of how long they will take, and therefore you don't leave it till it's too late. Now, because you can't come into college in person at the moment and have a look around, I thought I'd finish by saying something about the chemistry department. So we have 2 labs, and you'll have all your lessons in one or other of these labs. Both labs are well equipped for practical work. They've got fume hoods, so we can safely carry out more hazardous experiments that are important for A-level. We've got a preparation room in between the 2 labs, and there's a chemical store there, so all the practical work is done very easily. There are 3 chemistry teachers, as myself, Bridget and Zoe. We've been working together for 10 years now, and we work very closely together, and we develop all our resources together, and all the groups, whichever teacher you have, study the same work. And we have our technician Sarah, and she's going to be vitally important for your A-level course, because she will be getting ready the experiments that you do, including those for the practical endorsement, which is part of the A-level assessment. And we'll tell you more about that in September when you arrive. We're very, very approachable, and you could come and find any of us if you were stuck and needed any help. Now, what happens each week? So each week in chemistry, we will study the same content, whichever group you're in. So whoever your teacher is, it won't make any difference. You will study the same work in the same week. That means if you have a friend in another group, it's very easy to study together, and it makes it much easier to get help. We have a big emphasis on preparation work, so we want you to do something in advance of every single lesson. And you have 3 1.5-hour lessons a week, each of which is given a handout with some work on it for you to complete. There are subject plus sessions on Tuesdays and Wednesdays. So these are sessions where you can drop in and get some one-to-one help with anything you're struggling with, or if you wanted some extension work, you can come and get that through subject plus as well. And finally, each week we have a homework task, which we use to develop your understanding and consolidate chemistry we've done in the past weeks. We've been working together for many years, and we've developed a system that will, a highly organized system that will help you to study independently. So each lesson, I say you'll get a handout. Here are images of the 3 handouts that Year 1 students have had this week. They're numbered, so it makes it very easy to organize your file, and they're linked to a preparation work. And on the right, there is a chart of the preparation work for this particular topic. So they're numbered and they link up very carefully with the preparation. So we think that will help you, particularly in the first term, to get your independent study skills developed. Interested to find out more about chemistry and do some more work before you start, I can recommend these 3 excellent resources. There's a book called Head Start to A-Level Chemistry, which is quite easy to obtain. It's not a very large book, but it's very good at bridging the gap between GCSE and A-Level, so it's well worth a look. There's an excellent website called Chem Guide, written for A-Level chemistry students, and you could perhaps have a look at some of that before you come, some of the early topics in that one. And there's a really interesting set of videos I can recommend if you haven't found this YouTube channel called Periodic Videos. There's literally hundreds of videos on there now, all very interesting, about different areas of chemistry, and produced by the University of Nottingham's chemistry department. So an excellent resource there, and it's well worth some time looking at that. If you still have some questions, the college has a live webinar on Wednesday the 24th of June, and if you're interested in joining that to get your questions answered, you can go to the college website and follow the links to open evenings. If you have a chemistry specific question, or you need more help with the summer work, then you can use my email address and you can email me, and I will endeavour to help you with your question. Well, thank you very much for taking the time to watch this presentation. We're very pleased indeed that you're going to study A-Level chemistry at Long Road, and we really look forward to welcoming you to the college and to the department in person in September.